Hey everybody, what's good? What's going on? JB here, back with another CyberInsight live stream. Today we're going to be wrapping up the final few tasks in a TryHackMe room that we've been going over, I think probably the past month or so, dealing with using Wireshark to do different types of traffic analysis. So up to this point, I think we covered a few different things. We looked at Nmap scans, ARP poisoning, identifying different types of hosts, DNS traffic, and I think FTP. So today we're going to be dealing with looking at HTTP and HTTPS, and I think there's a few bonus tasks at the end we're going to knock out too. So I'm going to move over into the browser and we can start getting this lab. As always, if you have any questions, throw those in the comments section. We'll hit those up, and make sure you smash the like button, subscribe to the channel, all that other good stuff. So let's see, we're going to move over here. And this is the room that we're in, the Wireshark traffic analysis. If you didn't catch any of the other videos, you can just find those on the channel. I think we did, let's see, it was like these two first, and then these two in the last video. And today we're going to be looking at these final tasks here. So for this room, there is a machine you need to spin up. You can just hit this button here and pop that out in another browser. That makes it pretty easy. There's no attack box that you need for this room, so just need to spin up one machine. And let's just hop into this and see what's going on. So HTTP analysis. So the hypertext transfer protocol is a clear-based request response and client server protocol. You know it all from surfing the web, going to different websites and stuff like that. Although certain applications can use it as a way to send data back and forth between servers. So sometimes we see that with different types of API calls. It's a standard type of network activity to request and serve web pages by default, and well, it says it's not blocked by any network perimeter. I would highly say that that might not be the case. Don't always assume that, but a lot of places do have unfettered web access. Let's see. As a result of being unencrypted and the backbone of web traffic, HTTP is one of the must-know protocols in traffic analysis. So we're going to look at a few different types of attacks that we can try to detect with Wireshark. So phishing pages, web attacks, data exfiltration, and C2 traffic, or command and control traffic, for when a device has been popped and has some bad stuff going on it. So HTTP analysis in a nutshell. So if you remember the previous videos, really, we just kind of look at some notes of some specific types of things that we might be looking for, and then the Wireshark filter that's applicable to how to look for that type of traffic within the PCAP. So global search, HTTP2 is a revision of HTTP protocol for better performance and security. It supports binary data transfer, request and response multiplexing. I think the other interesting thing with this that you see, if we are using Wireshark to do analysis of HTTPS traffic, and we have the key to be able to decrypt that traffic, I think when we actually do decrypt HTTPS traffic, we'll end up seeing the Cleartext packets actually be labeled as HTTP2. So something to just keep in mind once we move on to the next section. So we could search for that using HTTP or HTTP2. HTTP request methods, so a get or post. So this is pulling information or posting information. You can see that it's a http.request.method and then it equals. So same type of format as a lot of the other filters we're looking at. Now, when it comes to both a cybersecurity perspective and operational perspective, knowing HTTP response codes or status codes is very helpful and very useful. You're going to run into this a lot. So you might not have to memorize all of these, but there's probably a few here that you are familiar with. If you've ever gone to a website and it hasn't populated because there's some type of issue, or the website you're trying to go to doesn't exist, we're used to seeing a 404 error. 200 means that things were successful and you're able to get the response back. A few other ones, unauthorized. If there's some issues going on with the server itself, sometimes we'll see some of these 500 errors. So good to know all of these. HTTP parameters. User agent is definitely one that you will see used a lot when we're searching for things. So browsers and operating systems normally identify something about themselves within this HTTP parameter. This is from a configuration perspective, this is helpful because it might have different types of rules within the application or web server to serve up different types of content in different types of formats, depending upon what is set with the user agent. So a lot of times things can kind of tell on themselves a little bit, depending upon what type of information is put in the user agent field. So something to be aware of. Request URI, this points for the requested resource from the server. The full URI, but we can kind of search for things within the URI that might be helpful. And then some other HTTP parameters, so like the server service name, the host name of the server, connection status, and a few other things. So as I mentioned with user agents, as the adversaries use sophisticated techniques to accomplish tasks, they try to leave traces similar to natural traffic through the known and trusted protocols. From a security analyst, it's important to spot anomaly signs on the bits and pieces of the packet. So the user agent field is one of the great resources for spotting anomalies in HTTP traffic. In some cases, adversaries successfully modify the user agent data, which could look normal. Security analysts cannot rely only on the user agent field to spot an anomaly. So they say never whitelist a user agent, even if it looks natural. User agent-based anomaly threat detection hunting is an additional data source to check and is useful when there is an obvious anomaly. So depending on how sophisticated the attacker is and what they're using, they might be able to hide their tracks when it comes to this, but sometimes they don't. And so that's a pretty easy way to do that. If you are unsure about the value, you can conduct a web search to validate your findings. I mean, you should do that in general. So looking for the particular user agent is just this filter. And then here we can kind of combine things. So if we're looking for something that contains a certain name that we know, or multiple certain names, let's see. And this is kind of just an output here, and we can see the user agent field here in the packet. We also can click on this, right click on this, and I'll show you how we do this once we actually get into Wireshark. Right click on this field and we can add it over into the columns here of stuff being searched, so it's easier to see it, so we don't have to actually dig down into the HTTP portion here, and we can actually search based off of the user agent. Log4J, something that we we all were quite aware of this past year. A lot of folks had to take care of and search for this within their environments. A proper investigation starts with prior research on threats and anomalies going to be hunted. So here are some of the filters that would work when looking for a Log4J attack. So the attack starts with a post request, and there are known Cleartext patterns that we would look for within packets, looking to see if this is being attempted to be exploited. So it starts with a post, and then the IP or the frame might contain the JNDI. And we can see that here within the get. See that's calling that there. And then there's also some user agent stuff that we might end up seeing there. So detecting suspicious activities in chunk files is an easy, great way to learn. They kind of say this in all these tasks we've gone through. So now we're going to jump in and see if we can answer some of these questions. So the first PCAP that we're going to open is this HTTP user agent file. And let's see what they're going to investigate the user agents and what is the number of anomalous user agent types. So let's take a look. We can open this up. Sometimes it takes a second for this to populate. I appreciate everybody dropping in, seeing some folks throwing some hi messages up in the chat. Appreciate that. Appreciate you dropping in at lunchtime, or maybe not lunchtime, depending on where you are. All right, so we're going to open this up. We're going to click on open. And let's see, we want to go to exercise PCAPs is HTTP, and then I believe it was the user agent 1. Okay, let's see if I can make this a little bit bigger so you can see that there. Cool. Let's see if I can actually move that a little bit so you can see. There we go. You can see that there's 54 packets there. Okay. Move that a little bit wider. So we wanted to see user agents that kind of look anomalous. So ones that kind of stick out that might not make sense. So we see this one. We can dig down into the packet here because I believe this is all HTTP. Like I said, we could right click on this. We don't want to apply it as a filter. I think we want to apply as a column. And now we've added that over here, and we can see this here. So we can kind of look through, put these in order. I think that probably put it in alphabetical order. Let's see if I can kind of move this over a little bit so we can see it a little bit better. Okay, so we want to look for things that look like it probably might not be correct, so, or should kind of stick out. So obviously we saw that this was something that might be used for Log4J, so we'll count that one. These Google Chrome ones look kind of normal. Microsoft WNS, I think that looks normal. Mozilla. Now this Windows NT 64, I don't know that that actually exists. So that's kind of one of these things where you're going to want to dig through and just make sure that things actually make sense. So that one could be one where someone's trying to make it look like something normal, but I don't think there was a Windows NT 6.4. So let's count that. 1, 2, Linux, Ubuntu. This Nmap scripting probably isn't something that we would expect to see, right? So that might be someone doing something. WFuzz, probably not. That could be another type of tool being used. SQL map, definitely not something that we would want to be seeing. So somebody's trying to map out some stuff there using another tool. So 1 for SQL map. WFuzz would be 2. Nmap scripting would be 3. That Windows would be 4. Windows NT 64. That'd be 4. And then this one would be 5. And I don't know if they would count a blank one as being anomalous, but we'll go with 5. We'll see if that is what they're looking for. No, so maybe it was 6 since there was a blank one. Yep, okay, cool. What is the packet number with a subtle spelling difference in the user agent? So this might be something that's throwing us off. Of course, that subtle spelling difference might have actually been what would have got us 6 and maybe not the blank user agent field. So let's see, all these Google Chrome stuff looks relatively good. Now, I think this is in alphabetical order, so hopefully, if there is something, maybe it will stick out. Mozilla, 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 Mozilla. More Mozillas. Yeah, so since it's in alphabetical order, that actually helps. This last one is attempting to look one way, but it's spelled a different way. So that is packet number 52. Okay, now they want us to open this other PCAP file, locate the Log4J attack starting phase. What is the packet number? So let's go and open that other file. There's a lot in here, so 45,881. Now remember, think it was saying that it started with a post request. So we could just start off looking for HTTP traffic. And we can just do that with just HTTP. We'll see if that comes up with anything. And kind of minimized it a little bit. Let's get rid of that user agent field. I don't think we need that. Okay. And then let's see if we wanted to look up a post. We also could search off of one of these here. Let's just see, but let's just go with this post request. Okay, let's see. I hate when that happens. There we go. Let's run that. So let's see. These are all posts. We can actually see that user agent right there hitting up that JNDI. So that might be the start, because these are kind of in order as far as when they came in. So looking for the start of whatever that is. So we could go with 444 since we see that it's starting with a HTTP post, and we see that the user agent is matching the signature that we would be looking for Log4J. Let's see, a basic command, and it looks like it has some type of base 64 encoded command here. So let's just say that's that, and let's try that, see if that is the answer. 444. Cool. Locate the Log4j attack starting phase and decode the base 64 command. What is the IP address contacted by the adversary? And they want us to enter the address in a defanged format. Remember, defanged format, we're going to kind of use the brackets. So let's see, let's open up like CyberChef. And we can just go and we can copy this out. So we're going to right click, copy value, move that over here. We're just going to go over into CyberChef. We're going to put this in here. And we are going to get rid of everything except that base 64 command. And we already know that it is base 64, so we're going to go from base 64. And there we go. So here's our output. It's a wget command, and this is the IP address. So we can drop that in here, and then we're just going to put some brackets around here so it's in defanged format. Cool. All right. That was good with HTTP. Let's move on to HTTPS. If you got any questions for any of this, you go ahead and throw those in the chat. We'll hit that up. But let's see. Decrypting HTTPS traffic. When investigating web traffic, analysts often run across encrypted traffic. This is caused by using the Hypertext Transfer Protocol Secure Protocol, HTTPS. We're all aware of this whenever we go to websites where normally we're logging in, should be using HTTPS. We go to banking websites and stuff like that. We normally see the little lock up in the top. So even here on TryHackMe, it's using HTTPS. And so that provides enhanced security against spoofing, sniffing, and intercepting attacks because it uses a TLS protocol to encrypt the communications. So it is impossible to decrypt the traffic and view the transferred data without having encryption-decryption key pairs. As this protocol provides a good level of security for transmitting sensitive data, attackers and malicious websites also use HTTPS. Therefore, security analysts should know how to use key files to decrypt encrypted traffic and investigate the traffic activity. The packets will appear in different colors as the HTTP traffic is encrypted. Also, a protocol and info details, so the actual URL address and data returned from the server, will not be fully visible. The first image below shows the HTTP packets encrypted with the TLS protocol. The third image demonstrates filtering HTTP packets without using a keylog file. So pretty straightforward here. Just some stuff we can look for: HTTP request, TLS. There is different parts of the handshake, very much like TCP. SSDP is a network protocol that provides advertisement discovery of network services. So we can kind of see down here what this looks like. Some ACK, SYN, ACK, hellos, stuff like that. So similar to the TCP three-way handshake, the TLS protocol has its own handshake process. The first two steps contain a client hello and server hello message. The given filters show the initial hello packets in a capture file. These filters are helpful to spot which IP address is involved in the TLS handshake. So for the hello, it's going to be request or TLS handshake equals type 1. And then we make sure it doesn't include the SSDP. So that would be the client initiating, and then the server hello portion would be coming back the other way for that part of the handshake. An encryption key log file is a text file that contains unique key pairs to decrypt the encrypted traffic session. These key pairs are automatically created per session when a connection is established with an SSL or TLS enabled web page. As these processes are all accomplished in the web browser, you need to configure your system and use a suitable browser, Chrome or Firefox support this, to save the key values to a log file. So that's really the only way that you're going to be able to get the keys for that, is if you configure it to actually save those for you. Otherwise, since it's session dependent, you're not going to be using the same keys later on when you're going to different websites, or even the same website after a period of time that the session times out and it has to create a new session. To do this, you will need to set up an environment variable and create a SSL key log file, and the browser will dump the keys to that file as you browse the web. SSL and TLS key pairs are created per session at connection time, so it's important to dump the keys during the traffic capture. Otherwise, it's not possible to create or generate a suitable key log file to decrypt the traffic. So actually using this, once you have that key log file, is really, really straightforward. You can just right click. So if we're looking at within Wireshark the packets and we know that's TLS, we can right click on that, go protocol preferences, pre-master secret log file name, and then it's going to pop up in this window. Just hit browse. You're going to find the file, hit OK, and then it will use the keys that you have in that file to try to decrypt the traffic. Excuse me. If you don't want to go that way, you can also just do it through the preferences option, select the protocols, and in essence, you're getting to the same place in the menu. It just depends on which way you want to get there. Viewing the traffic with or without keylog files. So without it, no HTTP2 traffic. With it, once it's decrypted, then you're actually able to see the data within that's encrypted within with TLS. And as I mentioned before, you're going to end up seeing that labeled as HTTP2 traffic. The above image shows the traffic details are visible after using that file. Note that the packet details and bytes pane provide the data in different formats for investigation. Decompressed header info and HTTP2 packet details are visible after decrypting the traffic. So depending upon the packet details, you can get a few different things: frame, decrypted TLS, decompressed header, and then the reassembled traffic. All right, let's hop into this and see what they say. So we're going to be opening the HTTPS exercise PCAP, and they want to know what is the frame number of the client hello message sent to accounts.google.com. So let's pop this open. Get rid of this. And we'll get rid of that filter, and that leaves us with 1760. So we want to look for traffic client hello message sent to accounts.google.com. So we can try looking at this here. So we said it's a client hello. So it's HTTP request or TLS handshake equals type 1 and without the SSDP packet. So let's move this over. Let's see. Did I miss? I think I might have missed the, yep, missed that first parentheses there. There we go. That looks good. Okay, so we got 20 packets based off of that. So then within here, we'll kind of move this up. We could search specifically, but let's just actually dig down into what we have here. Take a look. Server name. And then extensions. This is client services.google apis.com. That wasn't the one that we're looking for. We're looking for accounts.google.com. So let's move down to the next. There we go, accounts.google.com. So we ended up finding that, just so you can see where I went to get that, under TLS, and then the record layer, then handshake protocol, and then underneath that went down to extension server name, then server name, indication extension, and then found that down here. So you could hypothetically search on it just based off of this. So let me just put this in here. So I think this was 16 was the frame that we're looking for. But if we wanted to search specifically on that, just so you can see what that filter would look like. Just TLS handshake extension server name. So you could use a filter like this to end up finding that. Okay, decrypt the traffic with the keylogs file text file. What is the number of HTTP2 packets? So remember, we had a few different ways that we could do this. Let's see, preferences, we went under edit, preferences, protocols, if we go down to TLS, pre-master secret log file name, and we have that right there. So we can do that. And now we can go and search under HTTP2 traffic. And that leaves us with 115 unencrypted HTTPS packets. So let's see if that is the correct number. Cool. Go to frame 322. What is the authority header of the HTTP2 packet? Enter the address in defanged format. Okay, 332. Let's see, authority header, streams. Authority header is right here. So safebrowsing.googleapis.com. So we're just gonna copy that, copy it as the value, and we will move that over here. Let's see. And we're gonna put those brackets around it so it's defanged, which really just means if you put these around here, you aren't going to be able to click on it, and it will automatically load something that you don't mean to be going to. So that's why they call it defanging. All right, last question here. Investigate the decrypted packets and find the flag. What is the flag? Okay. So there should be like a way to look at objects that maybe have been found in the stream. Let's see. Analyze. Show packet byte statistics. I don't know if that's it. I think export objects from that, and let's see, HTTP. And so there's a few objects that would have been pulled through all this HTTP traffic. Let's see if this is it. We're going to save that, and we're just going to save it to the desktop. Now let's see if we get rid of that, move that. Yeah, there we go. Okay. So this was the object that was there, that was being pulled through that HTTP session. So let's copy this over. Looks pretty good. All right. Now we got these two bonus ones. Let's do it since we're here. Up to here, we discussed how to inspect packets for a specific condition and spot anomalies. As mentioned in the first one, Wireshark is not an IDS, but it provides suggestions for some cases under the expert info. However, sometimes anomalies replicate the legitimate traffic, so the detection becomes harder. For example, in a Cleartext credential hunting case, it is not easy to spot the multiple credential inputs and decide if there's a brute force attack or not, or if it's just a standard user who mistyped their credentials, right? We aren't able to see all that data kind of from a high level perspective. So as everything is presented at the packet level, it's hard to spot multiple username and password entries at first glance. The detection times will decrease when analysts can view the credentials entries as a list. Wireshark has a feature to help analysts who want to hunt clear text credentials entries. So some Wireshark dissectors, so FTP, HTTP, IMAP, POP, SMTP, so clear text stuff, clear text applications where we might end up finding credentials, are programmed to extract clear text passwords from the capture file. You can view detected credentials using the Tools Credentials menu. This feature works only after some of the newer versions of Wireshark, and it only works with particular protocols. So we can go and do this. So we're going to open up this bonus exercise PCAP. And then it wants to know what is the packet number of the credentials using HTTP basic authentication. And then what is the packet number where empty password was submitted. Okay, let's take a look at this. Let's get rid of this guy. Pull this back over kind of in the middle a little bit. All right, and then let's open up that bonus. And we'll get rid of that filter. All right, so there's 243 packets here. So we're going to go under Tools, Credentials. And this is all the credentials that it pulled from here. So we have a whole bunch of FTTP credentials, and then one HTTP. And so that was packet 237. What is the packet number where there was an empty password that was submitted? So we should be able to, let's see. Let's see if we can do this here. We'll move this over here and go 44. And we can see when we click down into here, we can see the request command, so password, and the argument that was passed back and forth. So we should be able to just kind of move down. Here, and I'm kind of just clicking on these, and it's moving back and forth to these different packets. We can see this changing over here. And this one here doesn't really have one, so 170 might be it, but we'll just double check. There's no argument passed there, so yep, let's go 170. Okay. Cool. And now the last one. I actually did a video on this. This is looking at using the firewall ACL rules creation. I think I did a video on this a week or so ago. So you can go check that out if you want to, but it's pretty much going to be the same stuff that I think we're going to be talking about here. So you have investigated traffic, detected anomalies, and created notes for further investigation. What's next? Not every case investigation is carried out by a crowd team. As a security analyst, there will be some cases you need to spot the anomaly, identify the source, and take action. Wireshark is not all about packet details. It can help you create firewall rules ready to implement with a couple of clicks. This is actually pretty cool. And it kind of a great way to learn how to write different types of rules depending upon where you're applying ACLs. So you can create firewall rules by using the tools, firewall ACL rules option. Once you use this feature, it'll open up a new window and you get a combination of different types of rules based off of IP, port, MAC address, inbound, outbound, allow, deny, things like that. So pretty cool. And they got a few different options for different types of rule sets you can do. So IP tables, iOS, Cisco iOS, so both the standard and the extended, IP filter, IP firewall, packet filter, and even the Windows firewall, which is pretty cool. So, so we already opened up this particular PCAP. So it says select packet 99, then create a rule for IP firewall. What is the rule for denying source IPv4 address? So 99, get rid of this. 99, highlight that, tools, firewalls, we're going to select IP firewall, and they wanted to know the rule for denying source IPv4 addresses. So we have deny picked here, source IPv4 address, so this looks like this probably is going to be the rule. See, they have source, deny by destination address, deny by source port, deny destination port, source address and port, destination port, and address. And the cool thing with some of these, you can do it by MAC address too. Okay, so let's move that over here. We'll copy this, drop that in here. Cool. Now just to kind of show you what it looks like if we wanted to do like from a Cisco perspective. Right, so you have standard ACLs, which are very basic and really only dealing with IP to IP communication. If you wanted to actually add ports, both destination port, source port, then you'd have to use an extended rule like this. All right, let's see what the last question here is. Select packet number 231. We're going to do IP firewall rule again. And what is the rule for allowing destination MAC address? 231 IP firewall rules. Let's see. We're going to go click on this. We're going to go to Tools, Firewall Rules. There's IP firewall. And then they wanted allow destination MAC address. So if we go down to the bottom here, destination address, but this is a deny rule. So we're going to unclick this, which is going to switch it to allow. And then allow MAC address. So that's allowing the destination MAC address to come in. All right, so we do that. And that should be it. Cool. So yeah, that wraps up this room and doing all the different things. So like I mentioned before, we did ARP poisoning and identifying hosts before, some tunneling or analyzing tunneling using DNS and ICMP, and then also taking a look at FTTP and how we can see what's happening in there, because that's a Cleartext protocol. So very easy to see what's going on. And then today we did the HTTP, HTTPS, looked for user agents, Log4J, looked at how to decrypt HTTP traffic to see what's going on within, and then looked for Cleartext credentials and how to write some firewall rules automatically using Wireshark. So pretty cool stuff. This was a fun room. Wireshark is definitely a tool set, whether you're on the engineering side, operational side, or cybersecurity side. It's something that you're going to need to know. You're going to end up using, and it's just a great free tool. So if nobody has any questions, we can go ahead and wrap this up for the day. Appreciate everybody dropping in. Trying to think some of the next videos that we're working on. I still need to go, I think, finish out the Windows local persistence room. I think we're maybe like halfway through that, maybe a little bit more than halfway. And then I have some more Cisco BGP labs coming up. And then once we get through those Cisco BGP labs, we're going to be looking at some overall Cisco labs, combining different types of technologies, so different routing protocols and stuff like that. And then actually going to start doing some Azure networking lab videos here in a little bit as well. So appreciate everybody dropping in. Hope you have a great rest of the week, and we'll talk soon. All right, bye.